nice bed.
I like
It, and I think it must be under the hill. That ditch was not that deep. It's so cool.
It's going to be right next upstairs to the landslide.
Yes.
And here's this.
Like it's
Now, just like stir it up, whip it up, and then let it settle and dry.
I like to let it dry out completely so that then, like with the 5-gallon bucket, with a lot of water, it slates down.
this you can like it's fluxing like that. This is getting to be overfired, whereas this is very dry still. You know,
And that has what in it?
this has 25% feldspar, 25 kaolin.
Okay.
And what's, I'm sorry.
And then the only difference with these is this is silica instead of the feldspar. So the silica is really like, it's not fluxing the body. It's just it kind of gives the clay bones.
In this one,
Yeah,
what's fluxing in this?
just the clay body itself. Like
is high in flux, so
Yeah.
you want to
like we
accommodate for
kind
that.
of surprised. I was sort of think that maybe this was fired to one actually and not 6.
It's wood ash.
But I would expect the one that was 100% to be even darker and a
fluxier,
bit more, yeah.
sheeny. So then this means that melting temperature is too low and we need the melting temperature.
Damn, is all I can
I really.
It means we could fire this lower. Like if we fired, say, to cone 4, maybe it would be great. Like looking at our
I'm really enjoying
clay on its own,
really balanced out.
well, we weigh it first,
And
then we boil it for 24 hours,
God
then we weigh it again.
knows what would happen if rice hull ash
Yeah.
came in. Because
And then
rice
you
hull ash
see
is
how
mostly
much
silica.
your-
It's supposed to.
So now, what if I
So
take
you want it to have
the
basically
ash
none.
and the hazelnut ash? Because then I'm gonna have the calcium, and then I'm gonna create something that's gonna have even more layers.
That's the exact question you have. So you have aluminum.
Okay, who's got the rice whole ash? I need it. I want some.
So cool. I'm obsessed
Is
with
it? Which one's that?
The
The rice hull
ash.
ash?
Thank you for
It's
helping
like
me.
salty looking and
Pretty.
Yeah, that's good.
shiny.
Pretty.
Read this.
It's really cool.
Look at that.
Divide all these by 3 to get the actual percent.
Focusing. There we go.
Oh, that's really helpful.
50-20.
So cool.
And this is brilliant.
Beautiful.
This is just, you bring in the
Looks like salt and pepper.
I know.
that's just
Now,
If you
can
look
I
at
say, I
Nuka
wanna take
glazes,
this, you know, I want to take this.
it has
the
the
same
quality
Glaze
of
recipe,
Nuka,
and I wanna take the
N-U-K-A.
hazelnut and I wanna
They
combine
often
it.
have quite a lot of
What should I do?
rice. So actually, it didn't have a great influence. You know, if we'd have added 1, 2, 3, 4, 5% of iron oxide, it would have been dramatically. You know, at maybe 8, 9% iron, you've got like black temakui, and so you would expect.
To be a little more drastic.
Yeah, and so this tells me that our clay body has, you know, it's definitely got some iron in it, but not quite as much as some low fire clays. You know? Like if you used our clay body as an iron slip, then it wouldn't do a lot. Like if you dipped it in a pot, a stone pot, and put it underneath the glaze, then you're not going to get a lot of iron. But then, so we did another test, which was adding it to the wood ash, central one again. So, and again, this glaze. And we added 0, 5, 10, 15, 20, 25%, just because, you know, I suspected maybe this might happen. So at 25%, you can really see the influence, you know.
That's a pretty high percent to change the glaze.
Yeah, 5% is actually quite nice. And this glaze on its own has quite a nice fat feel to it. Like I actually quite like this compared to. It's got more to it than this one. The wood ash is fluxing better than the granite, which makes sense because the granite like needs a bit of help to make it flux, whereas the wood ash is like, let's go. It's like, yeah.
More prone to flux, if you will.
Yeah.
So which one was this? This is the DP,
Devil's Playground.
that has more granite in it.
Granite. So
So the Mount Ashland might be similar to this?
It would be the same family.
Same family, with a lot of granite.
yeah, seeing the differences there. You know, they are pretty similar.
Yeah.
I thought they were the same one.
Can I see?
Speckles is like funfetti. Yeah.
On the Ashland one?
So this is Devil's Playground.
Yeah.
This is Mount Ashland.
Yeah.
No. This one is Mount Ashland. This
Oh,
is
very good.
this is Mazama
Oh.
ash. Yeah.
Sorry, I picked the wrong one. Oh, here's the granite.
Good.
Yeah, I mean, the thing, so we should look at these in turn,
Yeah.
but this was one test, you know, one thing, like, back in the days of where they first came up with glaze in China, it was basically a mixture of wood ash with the clay that they used, just blending those two things together, and maybe at 50-50 or maybe 40% ash with the clay is enough to make a nice drippy glaze. So, if we had had more time, that would be one test I would have done. Like, how much flux does it take to take this clay to a glaze?
Yeah.
And at cone 6, you know, you might need to use like a frit. That might be the easiest way to get it if you want to use less percentage. Something that I was talking with Jem about is like varying your fluxes can make for a nice result. So like not just calcium or not just potassium, but like throw some lithium in there. Like just varying your fluxes can be nice, and that can also make your melting temperature widen. It's kind of like baking. You know, if different sugars had, you know, meant that you wouldn't overcook your cake. You know, it's not like 18 minutes done, got to take it out. It's like it goes from 16 to 24 minutes. Like that's convenient, you know. So I think we can move these guys, or we can just move these over. I'd kind of like to talk about these in turn. Maybe should we just go over here?
I'll finish writing these. Yeah.
So each of these materials, basically we did the Ian Curry test, and we replaced.
Yeah, right in your way, Jen.
Oh, no, you're good.
It's okay if I'm right
So we
here.
replaced the whiting, which is calcium, that's the flux, and instead of that we used our pet materials. So each table had one. So this was hazelnut ash.
Yeah.
This one was the Mount Ashland volcanic ash. This one is WA, which is wood ash. Wood ash, yeah. MA is the Mount Mazama. Yeah. And then Devil's Playground granite. And then AR is the Altura rhyolite. Yeah. So, I mean, looking at these, my initial conclusion is, wow, they're all the same. But then you've got to look pretty close. You know? You're like, wow, did we have to do all of this to arrive? Like, great. But, so, I kind of wanted to do this to show you the method, because it's like a really great method. And but this is sort of like step 2. Like if I had a pet material like my wood ash that I want to use in a glaze, I would do a line, like a triaxial blend first. So I like to have my material that I'm trying to use a lot of at the top, and then a flux in the bottom left of the triangle, and then silica over here. So let's say lime and silica, that's what I normally start with my rock that I found. And so in that, you get to see what happens when you add too much flux and too much silica.
And they just all bleed together, or
It's similar to this, but like it gets you in the zone a little bit
faster.
Yeah, but this does the same job. It's just that we didn't add like a huge percentage of our pet material, so we didn't get like as much of a read on like what does it look like at 100% or 90 or 80 or 70%. You know, we kind of threw it in as like our extra little bit of juice. So with a bigger class, I would have done a triaxial first. Or even when you're at home, you can do a line blend, say, of your rock material, do it with silica, 90, 10, 80, 20, 70, 30, you can go all the way if you want. And then also with a flux like lime. So you can do the two edges of your of that triaxial. And that'll tell you a lot. That'll show you, does my rock need extra flux, or does it need stabilizing, you know? But, so talking about these though, what are some of the conclusions that you all have come to looking at them so far?
So these were high silica in
Yeah.
these corners, and they crack, they're drier and less glassy.
Yeah. So when you're doing the blending, yeah. So our glaze A in the top left corner is 90% nepheline cyanide, 36%. Oh well, actually not percentages. These are, we need to divide by 3. So 30% nephi up here. 12% of our pet material. What's 54 divided by 3? 17% of a frit. 40% kaolin. So this is really high alumina, because the kaolin's giving us the alumina. So you can see that is pretty dry, all told. You know, when we were talking about refractory materials, alumina is like the top. You know, if you're trying to make high firing bricks that go to really high temperature, you've got a lot of alumina in them. But the hazelnut ash is the one that's actually the most fluxed out, which is curious. The hazelnut ash actually in general has got more power, I think. Like these are all kind of in a reasonable zone, which is curious because most of these you've got great swathes of unusable.
And
you know.
there are some mistakes in there that might be giving the illusion that it was actually properly done.
Okay, yeah.
One of the rows got added more than it was supposed to of everything.
Okay.
So, yeah. So,
Right.
there,
Might
just to
be-
be honest,
Might be a little bit.
I have some notes that can tell me which one that was messed up. But yeah.
But it suggests that there's some element in hazelnut that is a flux, something like maybe it's high in magnesium or something.
It's definitely got a lot of fluxing power. Like looking at that. So then B, which is the top right corner, that has got. What's 52 divided by 3? 16% nepheline cyanide, and then 7% of our pet material, 10% frit, 25% kaolin, and then 25 silica. Wow, 25 kaolin and then 40 silica. So our B is very high silica. I mean, but D has 50%, so this whole right section is quite high silica. But B also has a decent amount of alumina, whereas D doesn't have any. D has more flux to it.
You said D was high in silica?
Yeah, it is as well, yeah. So a whole right side is very silly. Yeah. C has the most nepheline cyanide. C is our most flux corner, and that's got 50% nephsi, which is quite a strong flux. And there's got 20% of our material, 30% frit, so that's also flux. So that's why the frit, I think, is doing this fuming that you see.
Oh, I was wondering about that.
I think it's got like boron in it.
What do we use? 3134?
3134, yeah. And so that's like if you took boron or borax on its own in a little cup, then it would fume and like almost like salt glaze. So I'm pretty sure that's what's going on here.
Is that the color as well, or is
It's the orange.
Yeah, it's like flashing the clay. And these tiles are with the high iron. They're actually cone 9, 10, but they're high iron, as opposed to this which is cone 6 B-mix. So it's pretty low iron.
So this is drawing the iron out?
Yeah, it's affecting the iron and the clay. It's a little bit curious to me that like this with the wood ash, it's
The wood ash does that.
the wood ash does that
as
too.
well.
And there's wood ash all around this, whereas here and like the granite is not doing that, so you're not getting any fuming from them. So like if you dip a pot in a wood ash glaze, often there'll be a little like halo around the bottom of the dip, and that's got this little bit of fuming. And I think it happens a bit more with unwashed ash, which is what we had. So we looked at C. So D is 25% nephsi, 10% cut material, 15 frit, and 50 silica. Yeah. So.
That's kind of what it looks like on it.
Oh right. Yeah. Yeah. Nice.
That's pretty.
So what we see, so now thinking about our line blends, right? Each of these rows is a line blend. So our top left is really high alumina, and then it's going to pretty high silica and still quite a lot of alumina. I don't think we really want any of these, right? This is too much, unless you're maybe making like sculpture and you want some. Really, or like a Shino, maybe we're in like crazy Shino territory. And then
This
so
one cracked very quickly, though, right in the center and right out. If you could just control that shit.
yeah,
Right?
and then so A to B, A to C, sorry, down here. Yeah, the A is too high alumina, and C is a much more fluxy zone. So we should see in this some point which is like, what's the perfect amount that fluxes this? And so I'm looking at this kind of, each one's a little bit different, but yeah, this one's still quite dry there. This is nice. Yeah.
Visually, the like opaqueness of it
Yeah,
too.
right. Right, we can see that when you get more silica involved, it becomes opaque. And alumina's doing that too. And then the higher flux are more translucent and also more craze. So like when you get into trying to make your glaze fit your clay body, we were just talking about this, and you you want your clay to be right. Like you want your clay to have some feldspar in it, basically. But then you'll be adding some silica. You can reduce the clay and add silica to help the fit. You also need some silica in the glaze.
Reduced clay adds silica.
Yeah, and so the first step to trying to get your glaze to fit, I'd say, is adding more silica to your clay body. And you can do a line blend of that as well. So you could have like it with no silica up to say whatever 30-40% and see what happens. And there'll be a point in there where your glaze hopefully fits.
Which means it stops crackling.
Yeah, so like all this crazing, which, you know, it depends if you care about it, and maybe you like a bit of crazy.
Right.
It does kind of make the pot weaker, and I don't know. I'm not really worried about the food safety of it, but if you were going to sell, say, plates to restaurants and you want it to be like commercially, you really want your glaze to fit there. And there's something very satisfying about figuring it out and getting a glaze that fits.
Another thing that I noticed,
Yeah.
in particular, is the C corner here that's really rich in the frit. Some of them were really gassy, and I noticed as you got more alumina and silica, more clay and silica in, it settled down as you got away from that.
Yeah.
That was one, and the bubbling wouldn't be useful in a glaze.
No.
I mean, food would get trapped in these little things. That was one thing I particularly noticed on those.
Yeah.
That was cool.
And some of them are gassier than others.
The thing I remember
Aren't we
about
all?
C was how hard it was to knit.
C and
Ingredients you
I
did
kept
not want
dropping.
to-
Yeah.
C and
And
B
the
both
silica.
were like,
Yeah.
Oh yeah, they're a nightmare. So this is another thing when you're trying to make a glaze, like how it operates in the bucket. You know, a lot of these raw materials that you'll find, they're, especially if you have them at relatively large particle size, it will want to settle out. So you might want to put in something to help. Like I've used like a couple of percent bentonite and
It
Epsom
didn't
salts.
seem to help much.
It didn't
It
really.
helped a little, but it was just really
Well,
hard,
it's not
especially
gonna
with
help
ours.
like a one that just has
Yeah.
too much in it, right? It's just like not good.
There's other things you can use too. Like you can use some gums, like CMC
CMC is good.
and V gum T and V gum Sir. These things can also help it in the bucket.
Julie, do you stock some Vegum tea? It's kind of a white.
Is it,
Bentonite.
let me go look.
Amica makes a gum solution. Is that it?
Oh,
That's cool.
I don't eat.
and then
Those help.
so looking at the bottom level is quite interesting. So C to D. C is our super high flux. D is our high silica. And so there's some pretty good results here. Like that is pretty happy days. And so this one, that's pretty nice. So basically this is nice for seeing what happens with too much material. So you start to learn what's going on with your, you know, like we were talking about what makes a glass. You've got the glass former, which is basically the silica, stabilizer, which is the alumina, and then the flux. And so you can see in this grid what too much of each of those is. So when you go to your next step, it would be like picking, you can zoom in. So let's say I like, and it's still good to go a little bit outside of what you like. So maybe I like that, and this, and this, and this, say. So then this becomes my new test. And then you're like, oh, okay, we're kind of in the zone here. Do that once more, and then like, oh, now we're,
Adjust it by a few percent.
yeah. And so within,
I said yummy.
It
Yeah.
it is yummy. I love it.
and then so like,
Zone.
you can get to a glaze quality that you really like, and then you can play with it. So adding different oxides and stuff to color it.
Yeah.
So you could feasibly have like one glaze that you just really nail. It's a satin feeling, beautiful thing, and then but you could have 3 or 4 versions of it, different colours. Yeah. And so the other cool thing you can do is have like